Okay, so we're going to start distributive property using area. This one is going to be going over all of the odd problems, all the answers to the odd problems. So this video may take a little bit of time. Feel free to scroll to the ones that you need if you're good on the first page, but we're going to be going in order by odd. So let's start. So 5 times 4, what is this? Okay, so let's zoom in. So we have 5 times 4 here. Now, one way you've learned about this is you could cut it up into 5 different columns, 3, 4, 5, equal columns. So imagine those are equal. 1, 2, 3, 4 rows. So if you were to count this up, you have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And as you know, 4 times 5 is the same as 20. So we're really just doing our area formula for a rectangle, which is your length times your width. So let's go to number 2. Now, this is where it gets a little bit different. This one was review. Here, you have number 2 is going to be 7 and m. Now, in order to understand this, let's get number 1 in the screen as well. If you notice, you have 4 times 5 here, right? This here, you know to multiply. So here, you're going to do the same thing, but we're going to write 7 times m. We would know to cut this up to 7 columns. 3, 4, 5, 6, 7. I got to kind of squeeze it in. 7 columns, but we don't know how many rows to cut it up to. So this means that we need a placeholder. We know that we would multiply the same as we did here. So this becomes 7 times m is the same thing as just saying 7m. As you're going to notice as you go further in math, this symbol that you've been using right here, this times symbol, let's go to a smaller one, this times right here, that's gone. So when they're close, that's what you see. You hardly ever will see, well actually you'll not see as you go further in math, this symbol as well. So a lot of things change as you go further because this little dot to mean multiplication, that doesn't happen either. Just being close happens, or let me show you another way to write this. You could write this as 7 parentheses m, and that means the same as 7 times m as well. These are the 2 most common ways, and one more way, which is similar to this one. You could put the parentheses in 7 and the m in parentheses, and this also means multiplication. So your final answer on that one was 7m, right? Oh, I did number 2 for you as well. But it's fine, we did number 2 in class, so you should already have that one done. Number 3 and 4 I'll leave to you, since they are very, very similar. Now, this, I'll give you a hint. Your answer should have an exponent. So answer has an exponent. Let's see if you can figure it out. Okay, number 5, next odd problem. Find the area of each box in the pair. So if you notice, this side is the same height as this side. So to understand this one, if you go back to problem 1 and problem 2, you will see how to do this. So let's go to problem 1, or actually 2 first, because that's the first one we hit. We have a number times a variable. Well, all we did was say 7 and then m, so you still just multiply it. So we're going to do the same thing here, 4 and x. Simple enough. Now over here, what is this one? Well, the height is the same, so I should know that this is a 4 for the height. Now what is 4 times 3? 12. Okay, so we have this 4x here and a 12 here. So this isn't done though. We found out what's on the inside, but we need to continue this. So I'm going to draw this a little bit different. It actually is the same way as you continue. So I'm going to put it here, this off. And I'm going to put x plus 3 here, and I'm going to have a 4 here. Now where that plus is where I'm going to draw the line. What is 4 times x? 4x. What is 4 times 3? 12. So I did the same work. The difference is that I glued it together. So imagine these are two blocks and I glue them together. So what would be the operation when you glue something? Think about it for a second. Now that is how you should write it. You shouldn't just write 4x and 12. You should write something in between. And that in between, this gluing right here, should be the plus. Now I circled this plus, but it's not that plus that gives it that. It's your answer here. You see how it's a positive 12? That's what you're going to put there. So if this was a negative 12, you should be putting a subtraction sign there. Or you should be putting a plus, a negative, if you want to keep it positive. Okay, so let's go to 7. Number 7. So we have x and x here. Now, I know from number 1 said 4 times 5. So I know that I'm just multiplying it, right? But the problem is I don't know how many times I'm cutting here, and I don't know how many times I'm going to cut here. So I could be cutting forever. Could be cutting 100 times, right? I don't know. So we have to use placeholders, and our placeholders are going to be our x's. So I'm going to actually just write x times x. That way if I found out that, let's say x equals this, we're going to just say, let's say. So this is a hypothetical. That doesn't mean I found out that x equals 3 and you should write this on the paper. This means just, let's see what this means. So I'm going to take this 3 and plug it back in. If I have x times x already, I know that I can just plug in 3 times 3, and I now know that this block is equal to 9. So the x, or the variables, this x, they actually serve as placeholders, but there's a nicer way to write it. So how can we write this? Well, let's look. We have x times x here. Now, I wouldn't want to write 2x. 2x means something else. So there's definitely 2 of them. So is it 2x or x squared? I kind of already told you, but let's see what 2x means. 2x means 2 times x, which is the same as x plus x, right? So that's what 2x means. X squared, on the other hand, means x times x, right? So this one is much different. We are looking for the one with x times x. Where is it? Right here. So we want to write it as x squared. If you need to see that again, rewind the video. I am going to erase it so there's no confusion. And we are going to write x squared in the center. There we go. Now we're using the same kind of mentality as the previous problem. And the height of this is x, so the height of this one has to be x. Previous problem I am talking about would be number 5. So it was 4 and 4. This one was x and x because they're the same height. What is 2 times x? 2x. Now if I were to redraw this and glue it together, you do not have to do this. This is just to understand how to write these together. Gluing it together would mean that you are adding. So your answer should be x squared plus 2x. Okay, we're going to go a little bit faster. Number 9, have x and 4. Okay, if I gave you 3, always helps if you are dealing with a variable. Make up a number. Okay, I made up 3 last time. I'm making up 3 this time. I'm going to change it up. We're going to put something else so you don't think I'm always having to pick 3. I'm going to pick 5. X equals 5. What's 5 plus 4? 9. So this segment, to find out the answer, you would actually just add together. Now let's erase this, and we're doing the actual problem. So we have x and 4. How do you find the entire segment? You add it together. X plus 4. Are these like terms? Let's see. We have a number column. We have an x column. This is from the notes. Number, this would go in 4. X would go here. Are they like terms? Well, one is in this column, and one is this column. So no, they are not like terms since they are in different columns. So x plus 4 would be your answer. Okay, 10 is your problem. Let's go to 11. 11 is very quick. So we've already done a couple like these. Now, if you can see the evolution of this worksheet, we actually are doing what I was telling you, is gluing it together. And what is that process of gluing it together? It is addition. So I'm going to write 5x. I'm going to write 35. So this is 5 times x plus 7. And this one is your outside. So this is all your outside numbers. So if it helps you, write outside, and this one is your inside. So right here was your outside, right here was your outside. That's how you get this. Now you don't just write 5x and 7. You're obviously going to have the parentheses and the addition as well. Let's erase this. Okay, area sum, and then you write the inside. So one thing that I did add was the addition sign here. So that comes from the visual that you're adding this together. You are gluing these two blocks together. If you glue blocks together, you got to do addition. Okay, 12 is your problem. Let's go to 13. Now, there's only 3 of these problems, so I'm going to go back on my word, and I'm going to let you do these 2 because you need a little bit more practice than just 1. Okay, so instead of just doing 12, you're doing 12 and 13. Let's go to 15. 15 is going to be 7 times x minus 3, right? So we're going to circle 7 and drop this in. What is 7 times x? Now, if that's hard for you, let's slow things down a little bit. As you can tell, I like to slow it down. Don't learn if you're just going to rush through and I just give you the answer. So let's put the 1 right here. What is 7 times 1? 7 times 1. So you're only doing the numbers first. 7. Now your question becomes, how many x's do you have? No x's here. 1x here. So how many do you have? 1. Okay, now on to the next one. And notice how I make this circle. I'm going to make it very deliberate. There we go, this whole circle there. What is 7 times negative 3? So in other words, what is a positive times a negative? Negative. Oh, look, we already found that it was subtraction now. What is 7 times 3? 21. And you are done. Next one, 17. All right, so we're going to go to x times x. You're going to circle the x. You're going to drop the x in here. The numbers are 1 and 1. What is 1 times 1? 1. How many x's do you have? 2. And put the x there. Remember I did the commentary over here, or the notes, on the difference between 2x and x squared. This is a common mistake, which is why I went over it. Do not make this mistake. 2x means something completely different than x squared. 2x is the same as 2 times x, or x plus x. X squared is x times x. Make sure you are picking the right operation. So this becomes 1 times 1 is 1, x times x is x squared. Now, the next one, zoom in. So the next one here is going to be, what is 1 times 9? Make sure to include the positive. That's probably the biggest thing you want to do. Do not circle just the 9. You always want to think about what kind of 9 is it. So you're circling the whole thing. So now this addition reads as a positive 9. What is 1 times positive 9? Positive times positive is a positive. So you're going to put positive 9 here. And then this is going to be 9x. Okay, 19. 19. This is going to be 3m times, and if you need to, put your 1 here for 1m. 3 times 1 is 3. Now, when you have multiple m's, you're going to say how many m's are there? 1, 2, m squared. Not 2m, m squared. 3m times positive 2. What is 3 times 2? 6. How many m's are there? 1. So 1m here, 0 m's, so you only put 1m here. Now if you notice, because we're going to have to go backwards, on all of these, you would be able to go backwards this way. What do they have in common? Well, they had a 3m in common. So 3m squared here and 6m, they have a 3m in common. 1x squared here, 9x here. What do they have in common? They have an x in common. No numbers but 1 in common. 7x here, negative 21. What do they have in common? A 7. Okay, so 7 can go into 7 one time. 7 can go into 21 3 times. You can go backwards on all of these. Last one, put 1a, 1a, circle, circle. 1 times 1 is 1. A times a is a squared. 1 times negative 12 is negative 12. How many a's are there? 1a, 0 a's, a. So 1a squared minus 12a. Okay, go to the next page. Let's look at the first one as the example. So we are filling out everything the same. So since it's review, I'm going to go review from the previous pages. I'm going to just answer this. This is going to be 2x. Whoa, what happened? Let's erase that. Try it again. This is 2x, this is 12. Okay, multiplied and got that. Now from this, we are writing first our inside, this is our outside. So if you notice, the numbers on the outside are 2x and 6. 2x and 6. So we can make it to where this is in parentheses and this is plus. So this has to be parentheses, this is plus, right? The first one is going to be your outside. Write that to make sense of this. Your answer when you distribute is the inside. So we are now just labeling it, so then the goal is that we are slowly working our way up to where you understand how to work in factoring. So we are going to be going backwards. So if you notice, the level of difficulty goes up, or the level of, it's more the process. What you start with changes. So now go to number 3. So 1 is done. Number 3 has more blanks. So let's talk about how you get that first one. So I'm at 1 just to talk about how we got that first one that they gave us. Because on number 3, they don't give us that. So we got to say, how did they come up with 2? Because 3, they have a blank. Well, you are looking at what is in common. So 2 and 12 have the number 2 in common. This is their greatest common factor, the GCF. So we are back to GCF. So the 2 can go into 2, the 2 can go into 12. Now let's go to 3, so we can take that over here. We are looking at the number 6 and 48. What number goes into 6 and what number goes into 48? Okay, so let's see. 6 can be broken down to 3 and 2. These are the prime numbers. You can't break 3 down any more than just 3 and 1. So 3 is a prime number. So I'm going to erase this part because we couldn't do anything further. So 3 and 2 are the prime numbers. 48 is going to be 6 and 8 is 48. 6 is 3 and 2. 8 is 4 and 2. We can still break down 4, so 2 and 2. Bring down the 2, bring down the 2, bring down the 3. Okay? So if you need to pause the video and try another number, here, I'll give you a couple to try. 24, 32, try those two. If this process is hard for you, if you're not very good at your multiplication, this is something you want to work on. So I would try these problems, and then come and ask me after to check your work on this. You're making your factor tree is what this is called. So now back to these problems. I'm going to erase this, so copy that down. I'm going to erase that. Back to these problems. You have 3 and 2. What is this one here? Then you have 3, 2, 2, 2, 2. So basically if I multiply this back out, I'll get 48. So 3, 2, 2, 2, 2. What do they have in common? They have a 2 and a 3 in common. So what is 3 times 2? 6. Okay. Now this is the longer way to go about finding it. If you're good with multiplication tables, for smaller numbers, you're able to find this pretty quick. But if I gave you a huge number, you would need to know this process in order to find the, what is it called? The GCF. So this number right here is your GCF, greatest common factor. 6 goes into 6 how many times? 1. How many x's do you need to get to 1x? There's 0 here, so we need to put 1 right there. 6 times 8, is that 48? Yep, so that one works. So we can check mark that. Now, let's look. We want the outside first, then the inside. So outside first, then the inside. So we can say 6x, or, oh, why am I doing that? I'm doing the inside. Let me erase that, my bad. Okay, so we have 6x and 8. Remember, 1x and x are the same, so that's where I'm getting x. 1x and x are the same. So now I'm going to put parentheses and plus. So you have to add that part, parentheses and plus. So it becomes 6 times x plus 8, and your inside was 6x plus 48. Okay, on to the next one, number 5. Number 5 here. So we have 5x plus 35. You have equal to 5 times what? So this 5x plus 35 here needs to go in on the inside. 5x and 35. You are then going to find your GCF. What is the greatest common factor for 5 and 35? It would be the number 5. 5 times what gives you 5? 1. How many x's do you need to get to 1x? There's only 1 here. Just 1. 5 times what gives me 35? 7. So we're going to take this now, and you just plug it in right here. And we are done. On to 7. 3x minus 21. Okay, so 3x minus 21. This goes on the inside. 3x minus 21. We are factoring, so we're starting in inside, going to the outside. Before, if you notice, we were on the outside, going inside on the previous worksheets. So we're going backwards, and this going backwards is called factoring. So the other way is distributive property. What number do they have in common for 3 and negative 21? That would be negative, or actually we could just stick with positive 3. 3 times what gives me 3? 1. Were there any x's in common? No, but if there were x's in common, you would have to put it as your GCF. So no x's in common, so you're going to put 1x here. 3 times 1x, yep, 3x. 3 times what gives me negative 21? 3 times what gives me negative 21? Negative 7. Take this here, plug it over here, x minus 7. What was on the outside? Oh, that's this part. And you know that if you go back here and use this as your scaffolding, that you understand that, hey, look at that. 5 is the same spot as the 5 here. So 3 has to be the same spot here. So we're going to put a 3 right there. Okay, number 9. You have negative 3x minus 15, so you have negative 3 times what? So we're going to put negative 3x minus 15. What is your GCF? Are there any x's in common? No. So we're only looking at the numbers. So go back up. We're only looking at the numbers. So we have negative 3, negative 15. Negative 3 is what is in common. Negative 3 times what gives you negative 3? That would be a positive 1. Negative 3 times what gives you the x? Or how many x's are missing? Put an x here. So check your answer. Negative 3 times 1x, is that equal to negative 3x? Yes. Negative 3 times what gives you negative 15? That would be 5. So this becomes x plus 5. All right, let's go to the next one. Factor these, 4x minus 16. So what number is in common? So how are these different than over here? Is basically we're not using the visual anymore. We've already done this. If you notice, now we're only looking at this part. If you want this visual still, do it on a side piece of paper. That's completely fine. But now we're trying to do it straight to this notation. So let's try. And we are going to put 4x minus 16. What number do they have in common? What's the GCF for 4 and negative 16? So you could put the number 4. Know that it always is following under this for this worksheet. You have 4 parentheses and a plus or minus here and 2 numbers. So 4 times what gives you 4x? So 4 times what gives you 4? Let's do that one first. 1. How many x's are missing? 1. Check your answer. 4 times 1x, does it give you 4x? Yes. Now 4 times what gives you negative 16? That would be negative 4. And you are done. Now I'm going to erase these arrows so it looks clean. So 4 times 1x minus 4, and I'm going to erase the 1 because it means the same thing. Okay, 13 right here, 9x minus 81. So let's highlight what's important. 9, negative 81. Okay, so we're going to look at what's in common. That would be a 9. 9 times what gives you 9x? X. 9 times what gives you negative 81? Negative 9. So you have 9 times x minus 9 is your answer. Okay, let's go to the next one. All right, now the next one here is just more practice of the same thing. So I'm going to skip this page because it's exactly the same practice. Now when it gets to, let's see, some of the answers are a little bit harder because it has this squared. So let's do number 5. Number 5, you still put the x squared plus 3x. That is the inside. Here is the outside. So you have your GCF here. That's your x right here. X times what gives you x squared? X. X times what gives you 3x? 3. So this becomes x plus 3. And this is your outside, the other part. And you are done. So it's still the same thing. It's just a little bit more work. And you've already seen on other parts of the worksheet where we did x times x and got x squared. So it's not really new. It's just more things that you're doing at once. Let's go to 11. Factor these. T squared minus 6t. T squared minus 6t. So on here, okay, t squared minus 6t. We have, what are the common factors? Now, if you look at the hint they give you in the beginning, as when factoring expression, you have to consider that the common factor may be a variable instead of or addition to a number. So for this one, you have t here and you have a t here. So that was the point of this hint, is that you don't always have just the number. And I was trying to train you by, when we were talking about other ones, even though we ran into none that had GCF of, like on previous ones, we only ran into the GCF as a number. Down here in this worksheet, we start running into it as an actual variable. So it helps to go through and first, yeah, let's add the 1 here. What number do they have in common? Well, since it's a 1, they only are going to have a 1 in common. But how many t's do they have in common? So you're going to say, oh, they have just 1 t. So we're going to put just 1 t. So this counts as 2 t's here, 1 t, only have 1. Put your parentheses here. T times what gives me t squared? So this is going to be t. T times what gives me negative 6t. So this will be minus 6 here. For problem 13, let's go. So problem 13, you have 6 here, 21 here. Now, you can't just take out 6. So we got to look for a different way. So this is where our factor tree comes in handy. We're going to do 3 and 2 for 6. 21, what two numbers? 7 and 3. So all these are now prime numbers. So let's write them next to each other. 3 and 2, 7 times 3. So we have 3 and 3 are like terms. It helps, instead of doing it all squiggly like that, I should have done it like this. It's very nice for organization. If you have 3 times 2, then you go from least to greatest. Because look how nice I can now circle it. Just a preference, especially when you have a bunch of them. So this is going to be 3 here. So we're going to bring 3 on the outside. How many x's are in common? None. Okay, 3 times what gives you 6? 2. How many x's do you need to get to 1x? 1. 3 times what gives you 21? 7. Do you need a positive or a negative? Well, it's a positive sign, so I need this to be, since it's a positive here, positive there. Okay, let's see what else we got. Complete the factorization for each. So this is more practice. Now on this one, they are taking what you learned right here about the variables can happen to, and now you're combining that idea. So you're going to do variables and numbers. So you have 2 things to check for. Now, hold on. I don't know why. I think this is a typo here. Let's cross that out, and you'll see why this is a typo. Because they're right. 3 is one of your GCFs. So 3 is your GCF because 3 and 15, 3 goes into it. But also x is your GCF here. So x, because they have only one x in common. Now 3x times what? Let's do the number first, make it easy. 3 times what gives you 3? Oh, 1. X, you have 1x here. How many more x's do you need to get to x squared? 1 more. So let's count them. 1, 2. We needed 2. That works out. 3 times what gives you 15? 5. How many x's do you need? So there's 1 here. There's 1 here. You don't need any, so you can close the parentheses. So your answer is, I'm going to write it, well, let's just erase this one. That's why I would want to rewrite it. So your answer is going to be 3x times x plus 5. And I'll leave B for you to do. It's very similar. Oh, actually B, I see what they're doing. So I kind of combined A and B already. What they're doing on here, I didn't look at that ahead of time, but this is your final answer. They're just trying to show that you could take out a 3 first. So I'm going to erase this so then it goes with your paper. Only take a second to fix. So you can fix this on your paper as well. 3 times what gives you 3x squared? It would be x squared. 3 times what gives you 15x plus 5x. Over here, notice that you can also take out an x, so you would put 3x. And if you take out an x here, plus 5. Or you can do how I did it before and answer this. So number 2 answers, oh sorry, I didn't scroll over and see C. There we go. Now on this one, that's where they take out all the 3 and the x. So they combine A and B. So now when you take out 3 and x, it's back to what I originally wrote, x plus 5. So this is now your GCF. These aren't your GCF. This is just common factors. So this is just, I guess you could call it your CF, common factor. It's not your greatest common factor because greatest common factor would include even variables. Number 3. So we have, I'm just going to do A. Actually 3, since I did 1, I want you to do 3 all by yourself because 3 is very similar to 1. Okay, 5. 5x squared plus 15x. What is a common factor there? So we have 5 here, 15. So this is going to be 5. 5 times what gives me 5x squared? X squared. 5 times what gives me 15? Oh, look at me. I'm trying to tell you what to do, and I'm not even doing it. I put the 5s, but I didn't even look at the x squareds. How many x's are in common? 1. 5x times what gives you 5x squared? X. 5x times what gives you 15x plus 3. 7. So we have 6x minus 4 here. Anything in common? Nothing in the variables. This one doesn't have a variable. So we have 6 and negative 4. What number is in common? So if you see, there's a distance of 2. 6 minus 4 is 2. So that kind of clues me in. But I've been doing it for a while to where when there's a difference of only 2, I know that probably the greatest common factor that could be in there is just 2 because there's not enough of a spread. So when you have small numbers, the choices are much easier to make. So this one's going to be a 2. 2 times what gives you 6? 3. How many x's do you have in common? 1. 2 times what gives you negative 4? Negative 2. Okay, very good. So now let's look at the next one. You have 5 and 5, and then x and x. Now I'm going to take this one. I know I've been taking some of them slow, most of them. You probably already know most of this, but I'm going to take this a little bit slower in case you still are confused about GCF and why on the variable I'm taking out 1x. So if you write it out like this, now it's much easier to see what they have in common. So just one more way to visualize this. Notice I wrote the x squared as x times x. So I'm writing this. I'm going to take this out. So I highlighted it. I'm even circling it for you. So fancy. Go ahead and put 5x here. Now if you notice, I can add it, multiply by 1 here, and it's still 5x times 1. That way, all I have to write is what is left over. So whatever's left over is on the inside. Now, if for some reason that confused you, that's fine. Let's look at it the traditional way. 5x times what gives me 5x squared? X. 5x times what gives me 5x? 1. And we are done. Please complete the rest and have questions ready for me on the next class session. Thank you.